Welcome back. Have you ever had your code break in the middle of running? Should some error messages allow the rest of your code to run? Today, I'm going to show you how to create custom error messages and handle errors like a pro. Also, it'll keep your code running smoothly and efficiently. Let's turn your errors into opportunities for robust and reliable code. Hey guys, I'm Chris Gambill, and with 25 years in data engineering, I've seen just how important it is to write code that doesn't break under pressure. Whether you're automating tasks or managing data sets, handling errors the right way will save you time and headaches later on. Let's dive in. What are errors and exceptions? First, let's handle errors. So errors are actual mistakes in your code that will stop the program from running. Now, don't feel bad about this if you're a beginner. Even the most experienced Python programmers run into a place where they didn't indent correctly, where they forgot the syntax of something and mistyped something. It happens to the best of us. So it happens, you let the error run, figure out where your error is, and fix it. On the other hand, exceptions are events that happen during the execution of your program that disrupt the flow. Like trying to divide by 0, or maybe a file is missing, didn't get named correctly, didn't get dropped in the right place. That's exceptions. And you need to anticipate those and those types of things happening when you're writing your code. There is an easy way for Python to handle that, and today we're going to walk through how. Let's take a look at an example. So, the basic structure is try, except, and then there's a finally, which we'll discuss later on. But first, let's look at what you must have. So you have to have a try. You end it with a colon. You're going to do whatever code that you want to do here. Here we're doing a result. We're dividing by 0 so that we get a specific error. Next, you have to say except. So if you have a try block, you have to have an except block. Each of these indented sections are called code blocks. So we're going to say except. We're going to declare the exception as when the exception is a 0 division error, which is what we're creating here. We're going to say, oops, can't divide by 0. Now you'll notice here that instead of enclosing the string, which is the sentence here, by apostrophes, we're using quotes, and that's because there's an apostrophe in the middle of this. So you could do it either way in Python. It's good to be in the practice of using quotes, generally, because you will come across times where you're using contractions and you want to use apostrophes within your variables or within your print statements. And then you could switch back and forth if you need to use quotes, but you'd use either one. It's good practice to use the quotes instead of apostrophes. So that's the first section. Let's talk really quickly through this second section. It's a little bit more generic. I wanted to show a generic example here where it'll just print out the error and then show you that the code's going to continue on. So we have our try block, and we're going to just say with open this data test.csv. That file doesn't exist on my computer. R is just for read. If you missed our video that talked about how to open and read files with Python, be sure to go back and check that out. But that's what this is doing here. I'm not going to go through in depth. And then we're going to print the file. So basically, we're just going to print whatever's in the file if it exists. Otherwise, it's going to take whatever exception is returned. We're going to declare that exception as a variable called E, and we're going to print that error. And then finally, at the very end of this, I'm going to show you that the code still progressed through. So I just say I still moved on, right? So let's play this. Let's run this and see what we get. All right. See, oops, can't divide by 0. And then this section here printed out error number 2. No such file or directory. Like I said, that file doesn't exist on my computer. And then again, at the very end, I still moved on. So I just wanted to show you that it does, in fact, still progress through your code. So this is a way that you can handle an error that maybe is not super impactful to your overall pipeline, to your overall run of your program, and continue on with the rest of the code, letting the user or letting the programmer know, hey, there was an error. This is what the error was. It tells you kind of where you could go in the code to find it, and you could put whatever text in here so that you know, you could say like, I'm at line 4, right? And so that way the user will know, the programmer will know what line it was explicitly on. But you do all kinds of configurations there. Be creative, not too creative that people won't understand, but this way you could provide much more customizable error messages for, especially if you're designing a program for users. Coming up next, we're going to talk about how to handle multiple exceptions that you want to provide custom messages for. So sometimes you'll need to handle more than one type of error, and that's no problem with this. Python will let you catch multiple exceptions in the same code block. So again, your try and except is one full code block, and you'd have multiple excepts, or you could have the generic except like we talked about previously. But a lot of times you're going to want to provide specific errors depending on, or specific messages depending on what error or exception is returned. So let's take a look. We're saying, in this one, we're saying try. We're going to create this value, an integer, input a number, which will prompt the user for input. It's going to say result 10 divided by whatever that value is. If there's a value error, it's going to say that's not a valid number. If there is the divide by 0 error, it's going to tell you can't divide by 0. And then we're going to show you that it'll still move on. We're going to drop this other code so that all we return is actually this piece. So let's run this. We're going to put A in there. I'm going to move this up here so you can see. See, it prompts me for a number. Let's put A. That's not a valid number, you idiot. All right. And it says I still moved on. So in some cases, you're going to want it to break. So in some cases, you want the code to stop, but you still want to provide that custom error message. I'm going to show you how to do that real quick. Okay, so we're talking real quickly about how do you stop execution of your code, so stop your code from progressing on. If you hit an error, you want to provide a custom error, but you want to also stop your code progression if the error occurs. So this is how you do it. You're going to need to import a library. That library is the system library. It's just sys. And we're going to say sys.exit. And we're going to say 1. 1 is the code for an error. And so this way, it's going to stop once you hit this piece. It's going to progress if it says, oops, you can't divide by 0. Maybe, that piece is not a critical part of your code. Maybe you're going to say something like, we're going to say result equals 0 here. So if it is a divide by 0 error, then it's going to just replace that result with a 0 and move on with the rest of the code. That way the rest of the code processes with this different value. If they put in a 0, maybe that's, you know that generally when people put in 0, this is what they mean. So, and you could change this to say your value was replaced with 0. Due to not being able to divide by 0. And that way your user knows explicitly, okay, this is what happened, this is what occurred, and it will move on with the code. You'd even add some, additional complexity here, asking your user if you still want to progress, and then if they return a yes, then it'll progress, and if they return a Y, then it'll exit the code. So it could get as simple or as complex as you need it to be based on the needs of your program. So let's run this just to show you what happens. Let's clear this out first. Now, run this. We're going to enter A again just to show you. Well, let's enter 0 so you get to see I still moved on, that your value was replaced with 0 due to not being able to divide by 0, and it moved on, right? So you'd even say something like this, right? And still moved on. Your result was, we're going to say result. See? And it lets you know what your result was. So that is some additional information about how to break your code, how to break your code progression if you need to, and still provide that custom error message. All right, so now we've covered the basics, but what if you need to clean up or finalize something no matter what does happen, whether there's an error or not? Let's take a look. All right, this time we're going to introduce another piece. You'll see here we have our try, a couple of accepts, and then a finally. So the finally piece is going to be part of the code that executes at the end of this, regardless of whether the try block worked or the accept block worked. So, and at the end of this, we're going to say, I still moved on. So what this is going to do is it's going to try to open this file. The file doesn't exist. You may have seen a moment before where there's some error messages, and that was because I was just testing to make sure I didn't have a file.txt somewhere on the computer that it was going to find. Just double checking. But you could perform some other file operations here once you have that opened. You would generally use the with statement and go that direction. But basically, we're trying to open the file. It's not going to exist. If the file's not found, it's going to tell the user or the programmer, whoever's running the code, the file was not found, and that's what it's going to print out. Otherwise, if there's some other exception, then it's going to print that exception. And then finally, at the end of that, whether it found the file or not, it's going to exit the code. It's not going to ever make it to the I still moved on piece. But let me show you, in fact, that is what happens. Let's run the code. You'll see it printed file not found because the file is not found, and we don't get the I still moved on piece because, again, the finally piece ran and exited the code. So again, to exit code, be sure that you're importing the sys library, and then you could use the exit function within that sys library to stop your code. Generally, another use here will be if you've opened a database connection, if you did get a file opened and you need to close it, any type of cleanup, any type of, it's called kind of, if there's some junk collection that you need to do, happens naturally within Python as opposed to some other programming languages. But if there's some cleanup that needs to happen at the end of your execution, regardless of whether things happened or not, this finally piece is where you're going to put that. You're going to close your connections, make sure that files are closed, things like that. So next, we're going to talk real quickly about an analogy to help this really solidify the concept in your mind. All right, so it's analogy time. I know that you all love these, but so think of your code as a tightrope walker at the circus. Sometimes the stress and the anxiety is gonna raise to that level when you're hitting run for the first time after you've written a block of code. So writing the core logic is like walking across the tightrope. Everything works perfectly until something unexpected happens, like a gust of wind, you lose your balance. This is where the exception handling comes in. It's a safety net that runs below the tightrope walker. If an error occurs, instead of the entire performance ending in disaster, the safety net, which is in this case your try except blocks, they catch your tightrope walker, or they catch your code, allowing them to get back up and try again. So, just like the tightrope walker, your try except blocks, your safety net, allows your code to continue on. It doesn't die with that fall, with that fail. The finally block is making sure that the safety net is always properly maintained. So, it's ready whenever it's needed, ensuring that everything ends smoothly no matter what. So your finally block is kind of like your inspector going around making sure that that net is securely in place, making sure that everything is still running perfectly. Now, we're going to go over one last piece, and that is raising exceptions. So sometimes there's going to be cases where you want to raise an actual exception. You want to look like a full exception block. So in those cases, you would raise the error. You're raising, in this case, we're going to raise a value error, letting people know that age must be 18 or older. So basically, this function is going to check the age. Here, we're going to prompt a user for an age. And it says, please enter your age. And let's run the code just so that you can see what happens. Then we'll walk through what that syntax looks like. So watch. If I put my actual age, it's going to move on. No harm, no foul. If we run it again, we put something less than 18, then it gives us back an actual error message. So the full traceback tells you, what line failed. Line 11 is the line that executed. Line 7 is the specific line within the function that failed. So this is important troubleshooting steps to understand how, when you're walking through error messages. And here is our custom error. So value error, age must be 18 or older. So if you're creating a function, you need to raise an error. This is how you do it. Raise just means that you're taking it from within your code block, from within your function, and raising it to the execution level of your Python script. So that's what raise means. And that is how you create a custom error that actually triggers a full error message in your execution, in your terminal. So what's the toughest error that you've had to handle in Python? Let me know in the comments down below. If you found this video helpful, be sure to hit the like and subscribe button for more tips. Next, we're going to go over really quickly some best practices for writing robust code. All right, we learned a lot today, but before we wrap up, let me share a few best practices. So number 1, be specific when you're catching exceptions. Don't use that general except block unless you really need to. And sometimes it's a good catch-all at the end if you don't know what error messages that you're going to receive. But I would remove it before you put your code into actual production and that, a live environment. Log errors so that you can keep track of what went wrong, especially when you're putting things in production environments. You can use Python's logging module to make this easier. In a future video, we'll go over what that logging module is. Finally, avoid using exceptions for control flow. It's super tempting, but you can make your code harder to read and maintain when doing that. By using these steps, you'll write code that's not only more robust, but easier to debug and easier to pass on when you're ready to move on to another company or another position. So to recap, Error and exception handling is all about preventing your code from breaking prematurely or unexpectedly. Use the try except blocks to catch and handle exceptions, and the finally block to clean things up and raise your own exceptions when needed. Thank you so much for watching. If you want to see more Python tips and tricks, be sure to check out our Python tutorials. When you are ready to move on to SQL, be sure to check out those. And if you've enjoyed this video and enjoy watching me do these videos, be sure to drop a comment down below and like and subscribe. I'll talk to you again soon.